So in this video, we're going to be looking at velocity time graphs and objects moving on horizontal tracks. These are normally cars or trains or motorbikes. As you can see, we've got a lot of text at the start outlining the journey of this vehicle, passing point A when t is 0 and end up at point B when t is 40. So if we just read the question carefully, and if you look carefully at parts A, B and C, now normally the velocity time graph isn't part A, it's usually later on in the question once you've calculated some other elements. But I'd always encourage you to actually start with a sketch of the velocity time graph, and then as you build the picture you can actually add to it. But in this case, part A is actually sketching the velocity time graph. So if we just look at what this vehicle's doing, remember on a velocity time graph, please don't mislabel axes, label everything with their units, because the examiner tends to get a little upset when that's not done. So it passes point A when t is 0, so my A value is here, and it passes it at a speed of 20 meters per second, so I'll mark off 20 meters per second there, and it continues with that speed for 8 seconds. Okay, so there's the first part of my journey. It then decelerates for 10 seconds till it reaches a speed of 6. So I'll put my 6 here. Constant deceleration, so we'll put that down to there, and that can be 10 seconds, which takes me to t is 18. And it maintains this speed until it reaches point B at time t equals 40. And we are now complete as part of our velocity time graph. And as you can see, it gives a nice picture of what this vehicle's doing. Part B asks you to find the magnitude of the deceleration between 18 and 8. Well, that's obviously this part of the journey here, where 10 seconds elapsed. So what we're going to do then is probably use a SUVAT, I think would be the best option. So if we write our SUVAT, we don't know the displacement, we don't know the distance travelled. U we know was 20, and it decelerated to 6. A is what we want, the deceleration, okay, which is a form of acceleration, just slowing down. And T was the 10 seconds for it to take. Now, obviously, we've got V, U, A, and T. You should be getting used to this by now. V equals U plus AT. So 6 is equal to 20 plus 10A. And obviously, rearranging, minus 14 is 10A. So minus 1.4 is A. Now obviously the negative tells you what's going on. The signs are important here. A negative acceleration is in fact a deceleration. So I could state there that the deceleration is 1.4 meters per second. So my answer to part B would be deceleration is equal to 1.4 meters per second. I don't need the sign because I'm telling you it's decelerating. And as in our previous question, we've had calculate the distance A to B. And again, we split our velocity time graph into 3 sections. Notice how it's usually rectangles, triangles, or trapeziums. So for the first part of the journey, part A, that's just a nice easy rectangle. Remembering area underneath velocity time is distance. So 8 times 20 is 160 meters. Part B is our trapezium, and it's also SUVAT as we derived in our first few videos, and that's going to be U plus V over 2 times T, area of a trapezium. So 26 plus 20 divided by 2 times T, which was 8. So that gives me 13 times 8. So 13 times 10, sorry. So I've just made an error there. So let's redo that so we're not making any silly mistakes. So U plus V, so 6 plus 20 over 2 times time taken was 10. And again, I've done this in previous videos. Always recheck your workings out. So I've left these in deliberately. I'm not making silly mistakes. I'm doing it so you can see. So 26 divided by 2 is 13 times 10 is 130 meters. And then finally C, again, is just a rectangle. So we've got 18 to 40 is 22 times by 6, okay, which is 132 meters. And I think if you add all those distances together, you will get a total distance of 422 meters.